Hello everyone, this is lecture 211. I have taken some specific case for the UDL, which is up to at length of A from in A. This is a parabolic arch. Suppose this is a parabolic arch, this is a loading is partial, that is length A. Then how we'll find out the thrust? So we can always divide this W, take a small strip W into dx. Dx is distance and this is your x, this distance is x. We have taken W into dx as a load. So we can always have the equation dh 5 by 8 W into dx in place of W, HL cube x L minus x L square minus x square plus Lx. And this is the formulae which we have already learned in the previous lecture. So we can always go for this dh 5 by 8 WHL cube and this taken in the bracket and dx is outside. So we take this simplify. So we have simplified it something like this. So we are getting 5 by 8 WHL cube within bracket XL cube minus 2x cube L plus x4 and outside is differentiation dx with the dx. Now the total h will be the integration from 0 to the distance up to which the load is, there is a UDL load. So we have calculated h equals to 5 by input and 0 to a integrate this integration of whole thing we have done here and put 0 to a limit, and now we simplify it and find this value W a square 16 HL cube 5L cube minus 5a square L. In place of this is generalized you can say formulae, and if you put a equals to L by 2 you will find at the crown whole UDL partial half UDL. If you put L by 4 you will fill 1/4. Yeah, if you put A equals to total L you will find the whole UDL. So in this way, this general formula you can always find out the that thrust due to partial loading or full half loading, this can be done. So this is why we have derived this formula, and I think you could understand nicely and you can apply in your problems. Thank you very much.